Let's look at some of these word problems. Hunter rides her bike at a constant speed for 6 hours, helped by a wind of 2 miles per hour. Pedaling at the same rate, the trip back against the wind takes 9 hours. Find the total round-trip distance she traveled. So some important information we have here is that she's riding her bike at a constant speed for 6 hours. The wind is traveling 2 miles an hour. And then against the wind, she travels for 9 hours. And the question is, what is the total round-trip distance that she traveled? So recall that distance is equal to rate times time. In this case, Hunter's distance is what we're trying to find. Her rate is made up of the rate of the bike and the rate of the wind. Remember that when she travels with the wind is helping her, so we add the rates together. And when she's traveling against the wind, it's hurting her, or it's slowing her down, so we would subtract those rates. And her time is information that we know. So what are the variables in this situation? What is it that we're trying to find? We already established that we don't know distance. So we'll say let D equal Hunter's one-way distance. Okay, so it's the distance going only in one direction. It's not her round-trip distance. And then what else is it that we don't know? We know that her bike is traveling at a constant speed, but we do not know what that speed is. So the bike is the other information that we don't know. We do know the rate of the wind. So we'll let B equal the bike speed. Taking all this into account, we have D equals, remember traveling with the wind, Hunter's bike speed plus the wind speed of 2 miles an hour times her time traveling with the wind is 6 hours, is one equation. The second equation is on the way back, her distance is equal to whatever her bike speed is minus the wind speed times the 9 hours that it takes to travel. So here we have two equations in D equals form. So we have two choices here. We could graph, okay, we could use our calculators to graph, or we can really use substitution, because if distance equals b plus 2 times 6, but distance also equals b minus 2 times 9, then we can simply set b plus 2 times 6 equal to b minus 2 times 9. Solving, 6b plus 12 equals 9b minus 18. I'll have to move up here. If we add 18 to both sides and subtract 6b from both sides, we get that 30 equals 3b, and b equals 10 miles per hour. So Hunter's bike speed is 10 miles an hour. But remember, we were asked for her total round trip distance. So we had an equation that said D equals her bike speed plus the 2-mile-an-hour wind times the 6 hours it took her to travel. But now we know that the bike speed is 10. So distance, one way, remember, right, one way equals 12 times 6, which is 72 miles. So her round trip is 72 times 2. She goes there and back, which is 144 miles.